Welcome back! Today we're going to talk about Metaverse with a special focus on NVIDIA Omniverse. Of course, we not only talk about the Metaverse, but we will show a practical use case. Let me introduce my co-star and partner in crime. Go ahead, Gianni.
Hello everybody, thank you Clemente. Welcome to this new webinar.
And let me introduce our special guest, Natalia Malia. Hello, Natalia.
Hi guys, hi. Nice to see
Natalia.
you.
And finally, Alessandro Festa. Hello, Alessandro.
Hey everyone, this is Alexander Marcal.
So, before starting with our session, please tell us more about yourself. Go ahead, Natalia.
Okay, so I'm Natalia Malia and I'm a machine learning engineer at SmartCow. Over the past few months, I've been investigating this tool by NVIDIA called NVIDIA's Omniverse, and we've started to look into what this Omniverse could be like with respect to the Metaverse and how we could use it for artificial intelligence.
Great. And Alessandro, what about you?
So I'm Alessandro, Alex. I'm a senior technical product manager here at SmartCow, and I'm basically following the innovative project. And one of these is, of course, working with Natalia, our Lady Omniverse, as we call her, and our company, and actually trying to build something amazing that we'd really like to show you today.
Great. Let's start with the presentation.
Sure. So, like you say, Gianni, basically, and you, Clemente, is how about what is more Omniverse? We can build something around the Metaverse, and specifically the NVIDIA Omniverse. So let's get started and try to understand better what we're talking about. First of all, who is SmartCow? Me and Natalia work for this company. SmartCow is an AI engineer company. We're based worldwide. We have headquarters in Malta, but with offices in India, Taiwan, Italy, Singapore, and we just opened up in France. We basically focus on three kind of areas: advanced video analytics, applied artificial intelligence, and electronic manufacturing. More specifically, we are an NVIDIA's partner, and I'm really proud to say between those partnerships, for example, we are an elite partner at the NVIDIA Metropolis Software. Just to give you some names, there are only less than 10 elite partners worldwide, and we are one of them. So we basically provide both hardware and software solution. Hardware based on NVIDIA portfolio, software based on AI capability that we can actually inject into NVIDIA portfolio. But let's go back to the Metaverse. First of all, let's give a definition of Metaverse. So if you Google Metaverse definition, this is what come up. It's a virtual reality space in which user can interact with a computer-generated environment and other users. So this seems more to me like a sort of gaming consumer kind of world where basically you can land on those virtual world and basically interact with others. The original name comes from actually the blend of the two terms, meta and the universe, around more or less 1990s, more specifically from a 1992 book. But what actually can be defined as a metaverse in how today works? I define metaverse through three types of possible metaverse: the consumer, the gaming, industrial. And to give you a sense of those, consumer can probably go through the most practical example, could be like the Meta, Facebook, metaverse, where basically you can create avatars, you can interact with avatars in virtual worlds, you can basically buy stuff, or you can visit other places, and potentially it's like a real virtual world. Gaming, as an example here, for example, is Roblox, where actually you can interact with other users in virtual world that played around gaming. Both of them, they make use or even use, for example, of AR, VR. And I'm asking, for example, to Gianni, that is a super expert around that, actually, if can actually share some of the experience he has around that, or some of his thoughts about this kind of metaverse.
Yeah, this is one of the most of people related to VR and AR think of the Metaverse. My own experience has started from more than 10 years ago, and we at the time called just VR, but today it's more fancy to call it Metaverse, and it's something that you feel immersed in. That's the reason of Metaverse, like VR or similar idea comes from. Related to AR or mixed reality, instead you have the blending of what is real and what is digital, and then everything is becoming metaverse in the sense that we are in a universe that's beyond the edges of the reality or the virtual or the digital stuff.
Yeah, and you actually make a great point. That is like actually two make great point. One is Metaverse is not necessarily just the virtual reality. Sometimes it is this hybrid, this mesh between the reality, the outside world, and the virtual reality, where you can mesh things and you can play with things, so you can operate that. But also is an immersive kind of experience. I want to literally allow myself to get into a world where I can manipulate objects, where I can use those objects as if it was in the real world. And this is really important because it drives us through the third types of metaverse, that it basically is more focused around industrial research. The picture you see here comes from NVIDIA, and is really a beautiful example of research kind of metaverse, where actually NVIDIA built an Earth 2, a digital twin of the Earth, where they can simulate things like weather condition, earthquake, and etc. And they can actually use these to improve our capability of understanding the outside world. Now, those type of metaverse so far always been seen as a separated worlds, always been seen like touching themselves slightly. Like, for example, if you're using AR, VR, probably you can use them in all three of them, but they've never been really blended. So what NVIDIA actually built was this capability to create an omniverse where you can blend industrial with gaming with consumer. And how you can do so? Well, the entry point, that is actually the main topic of this speech, is about using actually a proper platform, named NVIDIA Omniverse. But within NVIDIA Omniverse, you have multiple tools, multiple capabilities that spans around all these three areas and multiple areas. So you can basically like create clockwise from the bottom right of the slide. You can create, for example, audio voice sync application, for example, for a kiosk, where you can have a virtual avatar that actually can talk to you, can communicate with you as if he was a human. Or you can go toward more gaming, where you can apply physics and the rules of physics actually to the avatar you created, where you can replicate the human movement, human behavior. And actually you can advance in gaming, or even just using the gaming experience actually to expand the virtual world. And then you go to the industrial. That either can be to research, as we described it before, or can be actually in something that actually replicate partially or totally a digital twin of existing scenario. Think about, for example, warehouses, or you can think about in, let's say, a traffic management solution that should basically replicate license plate, or should replicate the cars or a model of the car. So you can even model the cars itself. And again, back to the Janine comment, if I have an AR VR set, I can literally merge the description, the virtual description of a car, the architecture of a car I'm literally development, into an existing car, and understanding how those pieces merge one together, how they can change it, and eventually even simulate them. So the Omniverse is basically this as a definition. It's the combination of multi-mode metaverse with a nice specific focus on the industrial, but actually not forgetting the gaming and consumer worlds. So how do I start? How do I start specifically with NVIDIA Omniverse, where I can find information? So the first thing is you can download it. Omniverse and NVIDIA Omniverse comes with an enterprise or an individual license. The difference between them basically is just the enterprise is meant for companies that want to collaborate together with larger teams, while the individual one is for single contributors kind of people. The individual one is free, the enterprise is under trial, and then you have to buy the annual subscription. The biggest constraint probably you have is that to work in Omniverse, you need to have a machine that supports an NVIDIA RTX technology. So your NVIDIA GPU is not just a classical, but it needs to be an RTX technology that basically you can find it on the majority of laptops or desktop, or even on the cloud solutions. Then you have to decide what you want to do on Omniverse. If you're more a developer kind of person, so you're building application and you're writing code properly, or you're more on the creator side, means Omniverse is natively integrated with multiple outside connectors. Think about the typical 3D artist kind of tools, Maya or Unreal Engine or Blender or similar tools. So they have a rich portfolio of connectors toward external third-party tools that you can use actually to build those digital twins. NVIDIA offer free courses on both of the roles. So you can go there, you can start learning and start implementing. So this means that the first step is really free. It's just about downloading, install it. It's a one-click install, and then starting from the courses, the tutorial to build that. But what I can do as an example of NVIDIA Omniverse. So me and Natalia thought about how we can explain this, how we can give someone an experience around that. So I'm picking up some of the topics here. Let's say that we choose a use case as a description. Let's find a way to implement it, what skills are needed, and possibly go through a demo. So we really go fast on the next slide to allow Natalia to have time actually to go into the details. Let's say you want to build a solution within Omniverse that basically can create, for example, a license plate like the one here. There are multiple variables there, or parameters if you want. How can I create a realistic license plate there? Maybe to support LPR, NPR scenario. What are LPR, NPR scenario? LPR, NPR stands for automatic license plate recognition or automatic number plate recognition. Means you should create a realistic plate that support all the cases there as a digital twin, attach it to a digital vehicle, and then you can basically train a model against it to recognize it. And later, this model actually can act and inference against the real world. So the multiple parameters can be the way you generate numbers, Indian numbers versus US numbers versus Italian numbers. The size of the plate, maybe it's a rectangle like this one, maybe it's square, double line, etc. The color is a white background, is a green background, is a yellow background. Fonts you'll be used. Is it the plate clean, or it has, for example, dirt or scratches? Is it ruined? Is it blurring the things? Is the plate against weather condition? Maybe what happened to the plate when it's raining, when it's snowing, when there's ice, and etc. So all those are the initial thought you have to think about when you build such a solution. And this basically impact a lot the dataset quality you may have, because we just said, okay, I'm building the digital twin. Why? Because I want to use this digital twin against a model to train a model. Means I want to generate a synthetic data set. But the data set overall have many other challenges. The quality of a real data set that comes from the real world typically have a lot of challenges, like omitted values. They forgot to enter the value of the picture you get. Duplicate example, same picture twice, 3, 4 times. Bad doubles. This is not a plate, this is a cat. My model doesn't know the difference. So every time we will see a license plate, we say, oh, this is a cat. Bad feature values. Maybe there's something wrong there that actually can ruin my training overall. So this is why, for example, even bigger firms like Gartner says, well, synthetic data has a value that you can provide a higher quality data set. And because of that, we will see an increase of the generation of synthetic data. And guess what? Where you can generate synthetic data, NVIDIA Omniverse is a solution like that. So what we built, for example, was exactly to solve all the things we just described. If I can create a digital twin of a license plate, then I can add those parameters, those randomizers, rain, snow, fog for the environment, scratches, dirt, dent, discolored, and etc. for the physics randomizer, and then render a real realistic digital twin. We can even use, for example, in Omniverse, a tool named NVIDIA Replicator that allows us to generate a rich data set on all those parameters we input before on a scale, like thousands and thousands of times, every time, and then finally get to a synthetic data set. And with that, basically, I'm going to stop here talking and let actually Natalia jump in. This is, for example, a UI that the solution we described. I'll let Natalia actually to start from the very early point and go through a real realistic demo, how to actually work in Omniverse, how to actually go there. So Natalia, up to you.
Okay, thank you, Alex, and thank you for the great presentation. So let me just share my screen, and I'm sorry for any construction noise. This is everybody takes advantage of the public holiday, right? Oops, sorry. And let me just open my Omniverse instance right here. So can everybody see my screen?
Yes.
Yes.
All right, very good. So over here we have basically the UI that can come into Omniverse. So this is the developer platform specifically released by NVIDIA, which is called Omniverse Code. This is the kind of stuff that we like to use to create our, to develop our products and to create and prototype some stuff before we take it into Omniverse Create, which is more of the 3D and rendering oriented tool inside their entire ecosystem. In fact, once you load up Omniverse, you would see here, for example, all the different kinds of applications they have, and they have their own exchange as well, where they have they have a lot of collaborations and some agreements with other companies such as Sketchfab to load in assets to really build up this metaverse, which Omniverse is trying to encapsulate.
So
And-
Natalia, just a quick comment from my side. So what you're showing here basically means that the moment I launch Omniverse, I already have a rich library of things I can literally automatically install and use it.
That is exactly it, actually. In fact, they have some tools out of the box like Audio to Face, which is a machine learning operated application that actually takes in facial data from a 3D model and tries to map that facial data onto audio. You have Blender support to connect to Blender, to Maya, to 3ds Max. You have streaming clients that even starting to support some VR and XR at the moment as well. So we see that this ecosystem is consistently building up into something that is really working with the definition of the metaverse, and that it tries to connect to all the tools, it tries to create a linked ecosystem of things together. And this is what we started to experiment with. So going on to the demo we have, so this is Omniverse Code. This is the developer's platform where you can put in a nice, pretty scene, and you can load your assets in and you can start to play around. So we have actually our UI right here with a bunch of nice features for the entire our application, which Sandra just mentioned is the LPSDG application. And you get to play with all these parameters. So let me just pick a parameter to play with. Like suddenly switching all the lights on in my scene to see suddenly everything come to life. And this location is actually a digital twin of our office right in Malta. So it's pretty cool. And over here we have different things like camera control, for example, where we can play around with the camera, we can set things up, and we can look at our scene in different angles. This is of course very useful, for example, when I have several cars, like in this case, and I want to switch between them. Suddenly I'm looking at the Land Rover, which is not so well lit at the moment. I have a Range Rover in the scene, which is on a slightly better position. But here we'll move on to my favorite one, which is, of course, this gorgeous Mercedes that is actually provided by the NVIDIA Asset Store. So you don't even have to be a full 3D artist to be able to play around in the Omniverse. Of course, when you do have the 3D artist team, you can then boost things up to the highest level of detail and quality possible.
So what you're saying, Natalia, basically is that once I start having the scene, the basic scene, I'm also in a position where I can put a virtual camera and see the scene from every angle. That means basically that, for example, if I'm developing a solution that try to recognize the cars, for example, the plates for cars, and I want to put the camera slightly in the same position where I'm expecting to have the real camera in the real world, I can do that easily. And I don't even have to code anything. Basically, it's just something that comes out of the box from Omniverse, right?
Yeah, precisely. And that's some of the power of Omniverse as well, because now we have the power to create this end-to-end solution where if we have a camera, we gather data, we put it into Omniverse, train a model, and then we can take it all into this cyclic approach where everything kind of plays off of each other. And so we are really honing into as well, not just the metaverse, but the idea of a really good and pure digital twin.
So I have to ask you this, because I think everyone that is actually looking at us is basically asking the same, like, okay, this is really cool, but behind the scenes, I'm expecting like you're using some really mysterious and super complex language to develop this. Like, I don't know, whatever it is, something that nobody ever known. What are you using to code this? What language?
Like magic programming.
The magic program is actually Python.
You kidding me?
Super straightforward.
Cool.
Our favorite Python language. Yeah.
So it's interesting.
NVIDIA has actually released an SDK which uses Python as their backend to be able to control all this fancy stuff in 2, 3, 4 lines of code.
And by the way, I'm just stopping you for a second because I see we have a question from Paul. in the chat that basically Paul was asking us, are there pre-built models or do we have to build everything from scratch? Well, let me answer that quickly and then I'll let you, Natalia, also to chime in. The models actually are something that are outside of Omniverse per se. What Omniverse can do for you basically is allow you to create, for example, this, in our case at least, create a synthetic data. So you create a synthetic data set, and from there you can use the synthetic data to train the model. But nothing stops you actually to merge those two things. And in fact, it's something we are working on. So the capability, once the synthetic data is there, actually to apply the model directly to the data. And again, because like Natalia said, you're working on Python, that also means you can blend your models in the Python code and actually use it against the scene automatically. But I let Natalia eventually to comment on this as well.
Yeah, that's exactly it. And
Cool.
even in terms of 3D assets, you don't have to build everything from scratch either. NVIDIA has this very nice asset store where through their collaborations with popular 3D tools like Turbo, Squid, and Sketchfab. And you can just log in, you can double click, and you've got any assets you want. So you can build your scene without having to go too crazy either.
Yeah.
In our
And
case, sorry, please go on. Yeah.
No, just went to another question from Gaurav that was asking, can we do this stuff on Linux as well? Yes, absolutely.
Yep. NVIDIA Omniverse supports both Windows and Linux.
Yep.
So you can feel free to pick your tool of choice. All that matters is, as Alex has mentioned before, that we have that RTX GPU so that you can have these nice high fidelity realistic renders. That's the only constraint you have to think about if you really just want to jump into the Omniverse ecosystem.
Just a curiosity, what kind of machine are you using now for this demo?
So right now we're actually using a relatively simple desktop. I'm running it from my own personal coding machine, and it's running an RTX 3060. So it doesn't even have to be the biggest and the best GPU at the moment. It just has to be something that's reasonably powerful in order to handle this.
That's amazing because for other scenarios we require a powerful workstation, but you with the accessible machine are able to simulate a realistic environment in real time.
Exactly.
Very cool.
And then when we want to do further renders or higher quality renders, we have our own dedicated higher GPU and the better machines, basically. These just handle the workload themselves. So for basic development, yeah, we can use an accessible workstation. And then when we want to take it further, we have our dedicated resources to do just that. So it's up to how far you want to take it.
Super cool.
Very, very, very good.
So I'm sure that Natalia has some other tricks. Let her go
Yeah,
ahead.
this isn't where it ends.
Some magic
So, so we've been working with this Omniverse quite closely for a while now, and we've gotten a bit comfortable with what to do with it. So we know that in any application that handles 3D, the most important things you want to handle are to be able to handle translation, rotation, and scaling. And these are all things that come right out of the box in the NVIDIA Omniverse scheme. So if I want to take my current vehicle, for example, and I want to just change its position, it's as simple as taking these transformation tools, and suddenly my car is moving forward. So that's translation. We have a rotation, so I can rotate my car around any axis, and there it goes. And then we can do scale. So suddenly my car is as big or as small as I want it to be. And that goes into the basics of any kind of play you want to do in a 3D environment. So developing an extension is really playing on that. We want to change the scale of things, we want to change the motion of things, we want to change the position. And there's some I/O handling in terms of maybe you want to change some textures, maybe you want to change some lights and so on. So let's start with something simple. Over here I've shown you, for example, this is how we control our scene lights. This is just showing and hiding what we have available in the scene, and it really brings things to life where we can control something on a finer granularity, like day versus night scenes. This helps bring more life into our digital twin, because obviously we want our nights to be vibrant and we want it to be dark but not too dark. But at the same time, we want our day to have the sun kind of create the lighting by itself. And thanks to the physically based rendering system in NVIDIA, this is all handled as well in the system. I don't have to code anything to code how far these reflections go in or how far the lights on the vehicle illuminate everything. This is all here. So let's start with something interesting as well. For example, I want to do some AI, right? Some machine learning. I want to take a screenshot of this and I want to know where my cars are. Now I have the bounding boxes. And this is something that actually does come provided as a command from the NVIDIA Omniverse toolkit. They are able to help you create and select the bounding boxes out of the box. So for now, maybe let's not focus so much on the bounding boxes. Let's say that we're just trying to curate our data set. So let me just zoom in on this license plate, right? So right now it's looking pretty clean. There are no dents, there are no scratches and no flaws. So let's change that a little bit, because you know that the only time a license plate is this clean is right after you bought the car. The second you take it out, somebody's probably going to scratch your license plate. So let's do that. Now it has just a little bit of damage, but just a little bit, so let's give it some more damage. And suddenly have a license plate that looks like it's been through some things. And this is all completely configurable, so any vehicle I go to, I can just suddenly change the scratches level. So if I want to completely curate a scene that is in the way I want it to be, this is how I can do it. So let's take away the scratches. Okay, maybe you've been very good in the way you drive and you don't get scratches, but everything gets dirty, doesn't it? So we can now start to add some dirt on our license plate. Maybe it's just been a bad rainy day and you've got some mud on your license plate. That's going to obscure numbers. It's going to obscure the visibility of your license plate. So the more you have, the harder it is for the model to be able to distinguish. And that's exactly what we want. We want to, if we use this for AI applications, we want our model to be a bit bullied by the license plate we give it so it can be really, really good. It would be very difficult to distinguish this as an 8 even for the normal human eye. But now we've given the model the tools to do it, so it can start to outperform just thanks to this synthetic data generation and the power we give along with it.
I have this
So
question.
Hi,
Yeah, I have a
Gianni,
question
go
related
ahead.
to the data generation. You're currently using it interactively, so just changing some feature on the screen and see the results immediately.
Yeah.
Is it possible to automatize it? Are there APIs, or you have to build something around that to make it work?
No, it's automated. There's a button here that says generate synthetic data, and that's exactly what it does. I will showcase that later. So that's exactly what we're doing. This is just giving the user the ability to control, just because it could be interesting for a user to suddenly just see the way things change or see different positions or see different camera angles. But we also know that if you just don't want to see any of this, for you it would just be interesting to automatically have the dirt, the scratches, the number plates, the positioning, the cameras, the time of day, everything. You just want everything nice and easy. Yeah, same here, to be honest. So we've actually gone through.
Yeah, but what about the effects? Effects of the dirty or the scratches? Is something that you have to code, or something that you can have some built-in stuff?
No, actually, that is exactly the mean of NVIDIA Replicator. So NVIDIA Omniverse Replicator is a tool that actually does exactly that. Basically, the tool is able to pick up all the parameters that I was describing, so including everything else, like from weather condition to environment description, etc., and generate multiple variations of each of them through the range of each parameters multiple times. So basically, it's create for you an automatic data set that include all the parameters combining randomly. So this is why they call it domain randomizer. And this way, you will ensure that actually that is exactly what you expected. In that case, specific for license plate, let's say, for example, you are trying to figure out a number. You create another object, let's say a car. What it can do also is not just changing the color of the car, the size of the car, but also the position of the car, like the angle. So basically, you can have different angle at the same time, and this is completely automatic. And in fact, what one of the works Natalia is doing is exactly to integrate the generic synthetic data set with NVIDIA Replicator, exactly to do that. So the idea is like you can either, like she was saying, interact manually with the tool because you want to just figure out the parameter and then generate the synthetic data this way, or you can pass all the things to Replicator and say, off you go, generate synthetic data for me with all the domain randomizer. I just want to see the results, like a play that has slightly differences in the dirt, slightly difference in the scratches, combine it together, in the colors, and etc.
Let's answer some questions.
Yeah.
The first one is
All these adjustments can be done using code, yes, because the tool that we've just mentioned, Omniverse Replicator, is fully compatible and actually comes in natively with Omniverse code. So yes, you can create your 10K car samples, you can create all these facets yourself through some inbuilt code snippets that Replicator provides out of the box, and you can just tell it, randomize it, do it for me, take care of it. I don't care about anything else other than these details. And out of the box, it just comes ready.
The second one?
Okay, so we can add new feature, new value with scripting Unity engine. Can we add a feature like that way, or just we have to create an extension? No, I think it's pretty open. But I'm asking Natalia to confirm. But basically, you're pretty open. Let's say that the definition of extension is more like toward a capability that you want to expose to Omniverse.
Like a script or a module, yes.
Yes, exactly. But you also can build potentially a connector or an app directly, so you can expose the very same feature actually directly connecting to the external things.
If I remember well, there is a connector to export in the
Yes.
Unity.
Yes.
Sorry, in Unreal
Engine.
Unity.
Yes, that's the one. It even supports the newest version, which is Unreal Engine 5, so that's pretty cool. They're very up to date with their code base.
High quality render.
How big is the catalog of 3D models? I think that basically I don't know you, Natalia, but I would say that we don't really have an answer because the catalog keeps growing and growing and growing.
And NVIDIA keeps doing more partnerships with these 3D providers. So the answer would be, I guess, as big as the provider that you're looking at. And of course, some models are free and some are paid for. So it really goes hand in hand with that idea of the more they're doing, and the more the asset store grows, the more models you're going to get by definition.
And the last one for the moment, if we can create a digital twin of a human.
Yes, actually, to be honest, and I was mentioned to Jeff in the chat, NVIDIA has a specific extension for that, actually a specific app for that actually allow you to start from, let's say, sort of a skeleton of a human directly that you can build on top of it.
Yeah.
Not only that, you can also add to this audio-video sync. That means that you just not have the human actually, but you can put the human, especially the face, in sync with your audio and video. So actually the face is completely in sync with you. And you can apply all the physics to human. And again, if you use, for example, Replicator, you can, again, generate thousands of variation of this human actually to understand how his behavior can change in a simulation. I shared in the chat for the others a link to the documentation from NVIDIA around that. There's a couple of videos there, so everyone actually, the attendees can check those docs if they want. Cool.
Yeah.
Up to you, Natalia.
Yeah. So let's continue a little bit with this demo. So everything kind of interplays as we've been seeing. And so here is kind of the piece de resistance, if we want to go on that route, which is the generation part. With one click of a button, I've completely changed the look and feel of our license plate following an Indian dataset, Indian license plate format. So no matter how many times I click it, I'm going to have the exact output in the console box as well, because this is something I wanted visibility on for testing purposes. And over here, I'm just generating my license plates. And that's something that can then be saved and then can be used to further in AI. And that's what the options up here actually represent, because this is a fine granularity. Maybe at the moment, I just want to take a screenshot. I want this exact license plate. I like the lighting. I like everything, and I can keep it. Cool. I'll capture my scene. And there we go. Everything is saved. And then if I go into my directories, then I'll be able to find these images. I'll be able to find the metadata, and I have everything I need. But sometimes I need just a bit more than that. One image is not enough. So I have my Generate Synthetic Data button. For now, I'm going to create 5 samples just to make this quick, because we can't really wait for 200,000 images like a normal dataset would want. And over here, as we see, it's generating all the license plates. It's picking a camera, it's picking a time of day, it's moving the vehicles, it's adjusting the lighting, it's adjusting the license plates and everything. And all of this is completely dynamic in the moment, as we had mentioned earlier. And it's something that is also to be made compatible with the Replicator workflow. So we can really boost this as far as we want to and have all this generated data at our fingertips. We don't have to do anything. We don't have to adjust. We don't have to go into adjusting every single car. It's just a click of a button, and suddenly I've got myself a data set of 5 images, which has been finishing off in the time that I have been speaking. And
Well,
that's done.
while we're waiting, Natalia, I'm asking you this question that probably our audience actually can have. How about instead of capturing this synthetic data, I'd like to stream the digital twin? Like I want to get this as if it was, for example, a real stream of a video. Can I do that in Omniverse?
Yes, you can. Omniverse is compatible with RTSP streams. So if you want to be able to output any videos or take your metadata from any videos, all you have to do is get the data and you can plug it in. Because if we're familiar with Python, then it's just a matter of coding it in Python. And there are lots of libraries that are supported in the Omniverse ecosystem, like OpenCV.
Cool. That's super cool. Thank you.
Very cool.
Very cool. I have a question on the generation of the synthetic data. You say you just click the button and you can generate whatever you want on any number of different pictures. Is it random, or I can repeat the generation, saving also all the settings for this generation? I mean, probably with Python I can do it, but is something built in or something that you have to build in the extension? Or
It depends on how you want to set up your framework, I think. At the moment, because it benefits us more, we've set it up in such a way that it's randomized. But if we want something to be replicated in Replicator, that is also possible, yes.
okay, thank you.
It's amazing how it's simple to generate a dataset, and I'm imagining other scenarios where with a digital twin we can accelerate something in order to simulate the traffic on the other situations.
Yeah. No, exactly. And to your point, there's also, for example, tools already in Omniverse that allow you to regenerate an entire city map pretty easily. And then to that, you just need to add, of course, the 3D details. So this is the majority of effort probably comes from the 3D artist actually to put, all the details in the digital twin. But like you say, maybe I'm just interested in having, draw the flow of the cars in the streets just to simulate traffic, and then from there build my model actually to maybe catch and predict traffic flow, traffic queues, and etc. So that could be a use case, or could be something completely different. Let's say that I'm, for example, try to replicate a specific environment, industrial environment. I want to understand how it's built internally, a building, and etc. So that's all the use cases you can cover that, up to even further more advanced use cases. Maybe mesh the input that comes from the streaming of the information you have and mesh them as a pointer back in the digital twin. Cool. Go for it, Natalia. I'm sure you have a magic there.
Yeah, so, okay, well, I'm going to finish off this particular demo here, but working with Omniverse doesn't stop here. So let's just see how easy it is to do things in Omniverse. Because, well, we can talk about how generated, it's Python all we like, but let's actually go into something a bit more hands-on and actually see what it's like to code in Omniverse. So what we were saying before, the extension can be considered like a script or a module. It's a functionality that you want to achieve at the end of the day. So the more extensions you can create and link together, of course, the more you can build this up and make an Omniverse ecosystem to contribute to your own ideal of the metaverse. So while Omniverse loads, we have over here, this is the developer's environment, which is Omniverse code. And I just create a new scene, something totally new. So something that's really cool about Omniverse as well is that it comes with some environments right out of the box. So we can do some cool time of day simulation. So let me say that I want this cloudy sky because it looks nice. And all of a sudden, as it's loading in front of us, we see that we have this nice cloudy sky, but it doesn't end here. If we move these ahead, suddenly the clouds are starting to move and we can mimic our time of day. Suddenly it's night, suddenly it's evening. And this is something that does come out of the box in Omniverse as well. So that's really cool for time of day generation. So let's do something nice here. Let's create a simple plane, which would be our floor if we want it to be. Focus on it, and let's apply a texture, which also comes in an materials section here. Let's see, this octagon looks nice. So we drag and drop. And suddenly we have a floor texture as well. So we have two things now. We have a sky, we have a floor, we have our lights. It's very easy to set up. Let's scale this up a bit just for that little cool factor. And we can adjust as well the tiling of our UV to make it smoother to work with. That would be texture tiling somewhere here. Well, anyway, we can focus on that later. Actually, we didn't need it. It looks pretty nice as it is. Cool. And one more thing, let's add something into this scene just to have something to work with. So from our side, we've actually been extensively using the asset store, so that's something that we do. And if we go into our downloads here, let's pick something really cool, like, yeah, let's pick a dragon. And without having to do much work, we have a dragon, we have a floor, and we have a scene. Cool. So now we can see our dragon, and that's illuminated by this nice sunset. So let's start doing some cool stuff with this dragon. So we've put it into our scene. We've set up a very, very quick scene in Omniverse. And now we want to do something interesting with it, because looking at it isn't so interesting. So if we head down to the extensions tab and we create new extension template, we can put our extension wherever we want. I'm going to call this extension test or dancing dragon, because why not? And we have to give this an extension IT. So smartcow.ext.dragon. And this is a unique identifier which needs to be specialized. Otherwise, it will not be able to find the extension link. And once that's happened, it will automatically open a VS Code instance for you. And the extension will be loaded with some sample code that comes from the Omniverse ecosystem. Really, really cool.
Absolutely. And like you mentioned before, right now, basically you can apply all the things you were mentioned before. Like, for example, if I want to change the time of the day or something like that, it will be automatically dynamic, and all the texture and materials basically will, by inheritance, get the differences.
Exactly. So let's just load this up into our VS Code now, because VS Code also supports a live link. So if you can see here, we have our Dancing Dragon extension now. And let's do something cool with it. Let's make the dragon dynamically scale. So from this, all we need to do is add some imports from the Pixar module, which is what supports Omniverse natively to control the USD scenes. And let's just get a reference to our stage, which is as simple as getting the USD. So omni.usd to get that. We get the current context that we're working with. And all we have to do is get the stage. Now we have a reference to exactly what we're working on. It has some code right out of the box, so it presents us with a window and some clickables, as you see here, a label and a click me, but right now they don't do anything. It's up to us to make them do that something. So let's do that. For example, let me make the dragon scale up in any way I want him to. So let's change the window name to Unleash the Dragon. And over here, let's get to work. So we have a window frame, which is the window over here that's we're working with. And we want to, let's just keep it simple. Let's make it a slider, right? If you move the button left or right, you're going to change how big or small the dragon is. So let's delete this sample code, which is usually a helpful reference. And let's just start coding something simple. So we start with a plain function definition inside this UI component. And let's say we call this function a rescale. And in this rescale, I want to be able to access my dragon, which is as simple as referring to my old stage and writing get prim at pat. Once we do that, instead of having to find where my dragon is, I also have the luxury of right-clicking on my dragon and writing copy primpat. And that will come out of the box with referring to my dragon. So, cool, I now know that this is my dragon. So we need our value, which is new scale, and we'll refer to that later. And we need to adjust the scale, which is as simple as referring to this primitive, get attribute, and we can write, we want the scale, so that comes a representation inside something you can find in the NVIDIA docs as well. This is the XForm OP. It's called an XForm operation because the dragon is found within an XForm component, which is a native component in Omniverse that controls the positioning, the scaling, and rotation. And from there, it's as simple as saying scale. Now we need to set this to a new value. And to do that, we have to write GF, which is the graphics foundation of the Pixar library, and this is a vector tree. Let's do it as a floating point. This refers to our value. And so now everything has kind of come together, but we just need a few more bits and pieces. Like we want to have this refer to a UI. So Omniverse comes with a native, Omniverse comes with a native UI system. So let's do a simple label for now, which is just text. And let's do set the dragon size. This is just giving us the indication we want to know what this mechanism will do. And Omniverse has the UI component that also comes with things like buttons, sliders, grid boxes, scrollers, collapsible frames, and it's all found within documentation. So since we have been working so much with Omniverse, I know exactly what function I need to write, which is I want a scale slider, which is equal to a UI.floatDrag, which simply refers to a dragging button, which takes float values. We define our minimum, in this case 0 is enough, and we define our max, which could be, let's say, 1000.0. So we have a slider that takes values from 0 to 1000, and let's set the default value. So for that, I want my scale slider to be, we have to access the model, which is what controls the information, and set value. And let's say that since we had to resize the dragon, it won't be exactly 0. So let's say 20.0 to start off, and we can change this. And we do scale slider model. And now we need to refer to how these values change. And once again, present in docs, we can find that if you write add value changed function, my autocomplete also happily writes it for me. Lambda, which is a lambda function to access it. And that is the function rescale, and we pass m to it. So that's not too bad, right? But now rescale has to take a parameter, so we write model in here. And to access the value later, we just have to write model.get value as float. Oops. Float. That looks correct. So, okay. We've written a simple extension. Now, it's here. Let's test it. So, I'm going to press save. And without even trying, it's also hard reloaded in Omniverse. So while you're debugging and testing, you can just write your code and then you can test it out and see what happens. So we have our dragon selected. Let's give it a try. Okay, 20 was clearly too small, but that is okay. As we can see, as I move the slider up, the dragon gets even bigger. So let me set the default value to 100 then. And now as the scene's been restarted, yeah, that looks a lot smoother now. So we saw that the dragon was initially set to 100, and now, in just a matter of a few minutes, I've coded an extension and I've started creating something in Omniverse. It took maybe, 10-15 minutes? And that's it.
Very, very cool. Also impressive how it's simple.
Yeah, and everything is documented as well. And this also comes with some documentation pre-built. So if you want to have this UI documentation, for example, it's found natively integrated within the application, so you don't even have to Google search. If I want to know about sliders, here's my section. Float sliders, float drag. What we just wrote is right here at your fingertips. So you can see it, you can copy it, you can paste it, and make it work.
Great.
Yeah, I have a question on modularity, meaning now currently it's a demo, so you code everything inside a single file, a single class, whatever. Is it supported by the SDK to have some more structure? If there are multiple people working on the same project, they can structure the extension?
Yes, there is.
Okay, good.
In Python, the way we import things is the exact same. So if you just refer to your Python script that you've written or that your team has written, which is currently our approach, we import the modules that everyone has written and everyone has updated, and then we just put it all together in this final extension. So, yeah.
Also to your question, Gianni, is like we mentioned before, Omniverse comes with 2 licenses. The individual one that is free one allow up to 2 developers actually to work together on the code base. So they just not structure the code, but actually they can also work together on the code. But if you go with the enterprise license, basically there's no limit there. So it means all the developers, all the team of developers basically can work together on the same piece of code or the same structure, if you want, on the same extension altogether, and basically all those changes will be reflected on Omniverse as well. So the typical best practices from development can be applied also to Omniverse. So that means also, for example, the code Natalia is writing typically is, in our case, is basically pulled from GitHub directly. So this way we can actually do all the versioning, all the capability on GitHub as well.
Oh, cool, very, very cool. And what about also testing and unit testing component? Is it supported using standard Python tools or something built in Omniverse extensions?
Omniverse does have its own system of testing, but so far we've experimented mostly with Python purely because of familiarity. We would like to eventually go to see what Omniverse has to offer because there is something outside of the box as well, yeah.
Okay, cool. Thank you.
And by the way, I just want to comment out that even if it's true that everything seems really simple, this is because on one side, Omniverse is really a rich platform that allow you to really play with multiple things. But on the other side, I have to say kudos to Natalia because she makes everything really simple, but she's really have a deep knowledge about Omniverse at this point. So that's something that we need to recognize to her.
Yeah. Well, congrats. And a question is, how long does it take to ramp up on a brand new project, or given your expertise from ML engineer, you said, how long does it take to get used to these tools and this platform?
Well, to get used to it, it's not that bad. It's really more to do with the complexity of the current projects we're working on, because the challenges is really it's a new tool, so a lot of research has to go into finding the new ways to do the new things in the most efficient way possible, and it's really putting that together. It's not really about writing the code to scale or writing the code to move or writing the code. So the foundations of operation are here. It's just having all the interlinking components. It's kind of like making a game, right? Making a game is theoretically easy, but when you get into the nitty-gritty and all the components, it then becomes very, very difficult.
Okay, understood.
I take this moment to remember that the link for your presentation at GTC I am pasting in the comments, so please check it. Alessandro, you can tell us more about this session.
And actually, I have a last slide if you want actually to remind also not just the link that is actually live. I think that this Fireside Chat comes in a perfect moment because we are basically at 1 week, let me show them 1 week basically, from the NVIDIA GTC, the NVIDIA GTC virtual event that is totally focused on Omniverse between the other things. So there's plenty of session there where they can actually demonstrate the capability of Omniverse. We will be there in a specific session around NVIDIA GTC. where we demonstrate license plates synthetic data generator extension that we just showed today on September 19. Registration for the NVIDIA GTC is completely free. Also, for those actually listeners, if you look at the smart car, we will launch on the September 13. We will launch the Omniverse section of in the smart car area, but you can also learn all the other things smart car does, from a Jetson device based on the cameras up to the software we bring along with that as a fleet management solution and so on. Also, NVIDIA Omniverse has a Twitch channel with live coding and live session every week. It's super cool as a Twitch channel. They also have a discourse server, so I really recommend everyone who wants to start to Omniverse to join the Twitch channel and join the discourse server, because they really have a lot of information there. And nonetheless, last but not least, actually, the documentation is super rich. So back to your question, Gianni, about how much time is required to start, I think one of the cool things is that because you use Python on the back end, this really makes it super easy. If you already know Python, you can literally reuse your code there. The challenge probably is more on the learning the UI, learning the API stack to actually interact with the Omniverse, but it's all about the documentation. Maybe the most challenging part is on the 3D artist. They can use their native tools, but actually they need to learn how to actually integrate this to the Omniverse. But from a developer standpoint, this is something that's more or less transparent to us. And like Natalia in her amazing demo show us, basically you can immediately start with a digital sort of virtual world without having to do a 3D artist or anything specific. There's a really super rich catalog that you can go through. So that's basically what we are doing and what we'll keep doing. We'll keep posted everyone on our website through videos and other stuff on all the things we're going to the Omniverse. So that's basically it from our side. Basically, I don't know if Natalia want to add anything else, but that's what we are doing. We hope actually you like it, what we show, and then the things that we showed, because the idea was actually show you how to actually really work on the Omniverse.
Yeah, absolutely. Has been a great session, a great demo. Very interesting, and we had some in look with me and Tino, Clemente, and other the team. But very congratulations on what you presented, what you are doing. So keep up the good work, and we'll see you at the GTC session, of course. And then keep in contact with us. We have some ideas on how to use the Omniverse, and maybe we can have some chit chats about best practices and whatever you already learned.
Let's do it.
Yeah, let's do it, definitely. And like you say, Gianni, you're a super expert on AR, VR as well. So I think that could be really great ideas to combine those together in the future.
Yep.
Of course, you are receiving a lot of compliments, kudos. We love how Natalia make so simple some things that required a lot of time to understand. Anyway, kudos, and let me remember the opportunity to win an NVIDIA card just following the instruction that I copied in the comments. So register to GTC and attend to the Alessandro session.
Thank you.
Okay, that's all. We are waiting just a couple of minutes for eventually the last question.
There was quite a bunch of them, so that's really cool. Thank you for all
Yeah, I think there is a lot of interest around this kind of technologies. And the Omniverse is we are in the works, so we know the field, we know NVIDIA a lot, but most of the people around there probably not. So it makes sense to have other session maybe on these topics, from getting started to more complex stuff. So here now we have just the introduction to the ideas, the possibilities. But why not? We can discuss together if it makes sense also to add the new session and go more deeper on some topics, I think.
Okay. Thank you. For others,
Thank you again.
Curiosity,
everyone.
post in the comment below. I'm sure that Alessandro and Natalia, as soon as possible, can answer you. And see you next time.
See you. Talk
Bye.
soon. Bye bye.
Thanks, everyone.
Have a good
See you
day.
next
Bye bye.